Hello guys, welcome back to the Python lecture series. In the previous lecture we have seen or let's say we have completed all the data types up till sets, and today we are going to start with the dictionary, which is very important data type. Okay, so two data types which you guys are going to frequently let's say encounter in the whole journey of Python is, first off is that your list, and second one is your dictionary. Okay, so let me show you how dictionary actually looks like and how we can perform the things on dictionary. Okay, also once we complete dictionary we will also talk about one thing in the Python called as memory management and garbage collection. Okay, so today's topic is going to be all about the last data type called as dictionary and the memory management in Python. Okay, so if you can see, this is the set notes. If you guys remember, we have talked about the mutability and immutability factor till sets. Okay, so I'm going to create one more entry for the dictionary and then we will talk about dictionary as well. Okay, so I'll erase all of these things and then we'll talk about dictionary. So let's hop into the Jupyter notebook and let me show you how dictionary actually looks like and what is the definition of dictionary. So when I'm saying that we are going to deal with dictionary, which means dictionary is completely different from rest of your data types. Okay, when I'm saying rest of your data types means what? The data types which we have covered till now, let's say we have seen list. Whenever we declare list, it is going to be inside the square bracket. Whenever we declare tuple, it is going to be inside the parenthesis. Whenever we declare sets, it is going to be inside the curly brackets. But you also remember one thing, that when we were talking about the set, that was empty curly bracket, and we don't have concept of empty curly bracket set. It will always show you the thing dictionary. From this you can make the conclusion that dictionary also start with the same set of brackets. Okay, let me show you. Oh, this is something, let me delete it. Nothing related to our reading. Of course you're going to read that, but not now, maybe later. Okay, so let me check also if I have given you some homework. I guess no, we have completed till sets and now today we have to start with dictionary. So let me give you the heading of dictionary. So dictionary is the full term. We use the abbreviation dict for the dictionary. Okay, how we can declare dictionary? Now this is the question. So for the declaration of dictionary we use the curly brackets, the similar curly brackets. But what is the difference between set and dictionary then? Let me erase all of these things and let me tell you. We will talk about dictionary. Okay, we have completed till sets. We have to understand dictionary, and similarly we understood set we talked about set. We are going to understand dictionary in the similar way. Okay, can we perform indexing on slicing, how to declare empty dictionary, is there any possibility that we can declare nested dictionary, what all data types are supported. We'll see all of these things for the dictionary. Okay, let me erase this one as well. Okay, picking up the pen, now giving the heading here as dictionary. Now dictionary is again one non-primitive data type. What is this non-primitive data type talks about? This non-primitive data type says that we can declare the dictionary. Let's say my dictionary name is X as of now. We can declare dictionary within the curly brackets like this, as similar to that of set. Now what is the actual difference between the dictionary and the set? So for the actual difference you need to understand the declaration of element is completely different in set. We declare elements separated with comma inside the set, right? Now in dictionary we have a concept of key value pair. Okay, let me write it down. Okay, so whenever we are having key value pair, we are going to declare that as dictionary. You can declare multiple key value pairs inside the dictionary, there is no limitation. Okay, but I'm saying key value pair, you have to declare key separately putting one colon, then you have to declare value. Okay, so let's say how your dictionary is going to look like. Let's say this is key 1, value 1, and this is one element. Putting comma, key 2, value 2, second element. Putting one comma, like that. You can declare different key value pairs inside the dictionary. Also understand this thing. Yes, we are talking about key value pair inside the dictionary. Now we have to treat keys differently and values differently because they follow individual characteristics, which means we have some of the characteristics available for the key and we have some different characteristics available for the value. So we have to understand the characteristics of the key value to understand the element of the dictionary, and later we are going to understand the whole dictionary itself, how dictionary behaves. Okay, so in that sense, coming back to the point, how we can declare a dictionary, that we will see in the Jupyter notebook. Let me take you back to the Jupyter notebook. Suppose if you want to declare empty dictionary, you can simply write dict of empty like this. Okay, if you want to check the data type, you can simply mention dict of emp. You will see it is giving you the answer as dictionary. Okay, now if you want to print this dictionary, simply write it down and run it. You can see it is showing you empty dictionary. So both are the possibilities. Whenever you want to check the data type, if you guys already remember that we have a built-in function called as type that will help you to check the data type. Now we also have one built-in function for printing the answer. Let's say that is print. Okay, and it is giving me the empty dictionary. Now we will talk about dictionary filled with different type of elements or values. Okay, so let's say I am declaring one dictionary like this, and I am going to declare key value pair inside this. Okay, so how we are going to declare key value pair? Let's say first I am declaring the key like this, name, and then I'm declaring the value, let's say Python, putting one comma. Now understand, this is going to be your one element present inside the dictionary. Now age, let's say 50. Now subject is programming. So basically what happened, if you are going to count how many elements are there present inside this dictionary, you will see the value as 3. Now the question arises how we can count. Okay, now guys, this is completely, I'm going a bit off track because I forgot to teach you this built-in method. Which built-in method I'm talking about? Length built-in method. So basically, length built-in function. Okay, so length is the built-in function as that of your type and print, and we write length built-in function like this. It helps us to tell the elements present inside the data type. How many elements are there? Element count, you can say. Suppose if I have 5 elements present inside the dictionary, so this will give me the count of the element present inside the dictionary or list or any other non-primitive data type. Also understand that this is only going to work for non-primitive data type, because you guys know this non-primitive data type follows the collection of elements, right? Which is not the case with the primitive ones. Okay, so let me show you. If you count if you check the length of this dictionary, it is going to show you the length, it should be LEN, the length like 3. Okay, which means it is telling you that we are having 3 elements present inside this dictionary. Okay, now again moving forward, we have seen the different type of elements. Also you guys notice one thing, that I have only declared string type of data. So don't feel like we can only declare string type of data. No, there is no necessity. You can declare any data type that we will see. Okay, once we bifurcate the keys and values separately, we will see what all data types you can declare inside the dictionary. Now let me copy this dictionary and let me take you to the visual tutor. Let's try to analyze this bit more, how actually dictionary looks like in the visual tutor. Okay, let it get open, pasting it down right here. Now visualizing it, you can see if you give it a good look, you will notice one thing, that it is somewhat looking like a table. Tabular kind of a structure is coming up. When I'm saying tabular kind of a structure, you need to understand that previously for all the data types there was indexing that was helping us to pick the elements present inside those data type, right? Now here in the case of dictionary, we have keys which are acting as the index. So whenever I want to pick up any element out of the dictionary, I can pick that up with the help of the keys present inside the dictionary. Okay, so you can say that dictionary does not follow indexing, but yes, if I want to extract the element out of the dictionary, I can treat the index as the key of the dictionary. Okay, I can pick up the key of the dictionary and extract the values, but it is not the other way around, guys. Suppose if you want to pick up the value and try to extract the key, it is not possible. It is only one way, that you can pick up the keys and extract the values. Let me show you what I'm talking about. Let's first write down the first characteristic of the dictionary. So I'm erasing this thing as of now, and we will write down characteristics number 1 for the dictionary, that it does not follows indexing. Okay, chalo, let me write it down. Does not follow indexing. Your dictionary does not follow indexing. This is the characteristic number 1 for the dictionary. Now moving back, but if you need to remember that if you want to extract the element, since it is not following the indexing, you can do that with the help of keys. Let me write it down. But you can, or let's say one can, extract the values with the help of keys. Okay, but if you want to extract the values, you can do that with the help of keys. Also understand one thing, that it is not the other way around. You cannot pick up the value to extract the key. Okay, but yes, you can pick up the key to extract the value. Okay, now moving to the next part, how we can do that, right? Whatever I am saying, that you can extract the value with the help of keys, how you can do that? First, you have to simply mention the name of the dictionary, or the dictionary from where you want to extract the value. Also, you guys remember how we perform indexing? As I told you, we are going to consider here in dictionary we don't have indexes, but if we want to perform the extraction, we will see that we can perform the extraction likewise similarly to that of indexing with the help of key value pair. So we are going to use the square brackets. Now guys, always remember, whenever the data extraction is happening from the data type, whenever you try to extract one or two elements from the data type, always we are going to choose the square brackets. This is your dictionary underscore 1. You want to choose or extract the values out of the dictionary, you have to mention the respective key of that value. Suppose I want to extract programming, I'm going to mention subject here. Okay, run this. You can see it is extracting the programming for you. Likewise, you can extract. Okay, so I guess we were talking about the dictionary and how we can extract the elements out of the dictionary, right? So we will be continuing with that only. Yes, so let's say this is the normal dictionary. We will talk about how, what all data types you can declare inside the dictionary, and what all data types are supported to be the key, and what all data types are supported to be the value. Okay, but as of now we are just understanding the dictionary bit more, let's say deeply. Okay, now this is dictionary underscore 1 and then subject. With the help of the key we are extracting the value. Okay, now one more thing, If you guys remember, I have shown you the dictionary in the visual tutor like this. It is looking like a table, right? So whenever you try to create dictionary, always understand that we are trying to create a table where these keys are going to act as the indexes of the table, and the values are going to act as the values of that table. Okay, now this is your let's say, again coming back to the dictionary, where you can add or remove the elements from the dictionary. Okay, how we can do that? Let's say, suppose the way we are accessing the elements, right, the same way we can add the key value pair inside the dictionary, and we can remove the key value pair from the dictionary as well. Okay, how? So let's say I am writing dict underscore 1, and I want to add one new key. So I am going to mention the name of that key. Let's say the name of my key is hobby. Okay, I'm putting one equals to, I am saying that I'm going to assign some value to this key, and hobby is, let's say, unknown. Okay, this dictionary 1 is signifying that we are talking about this dictionary. This is nothing but the key, and this is nothing but the value. Okay, if you are going to run this cell and print your dictionary underscore 1, you will see you are having one, the dictionary is same, this is the similar dictionary dict underscore 1, but we added one new key value pair in the dictionary. Let me write it down. Adding new element or key value pair in the dictionary. Okay, now let's say if you want to remove, we will talk about removing later, but as of now let's see a basic understanding for the dictionary. Now let me tell you one more thing. Suppose if you want to replace some value, you cannot replace keys, guys. Okay, if you want to replace the values, how you can do that? First you have to access that value with the help of the key. Let's say I want to make the age from 50 to 60. How can I do that? I'm going to simply write the age, putting one equals to here, and let's say I'm going to write the age as 60. Also remember, guys, previously when I declared the age, it was string. Now I'm trying to convert that into integer. Basics. I'm running this cell, and if I want, I can also print this dictionary again and check if the modifications has been done or not. You can see we are having dictionary underscore 1 as, sorry, let me refresh all the cells, then you will see the changes. Dictionary underscore 1 with the age as 60. So as of now, what I have seen, how to replace the value, or let's say how to modify the values with the help of keys. Okay, so these are the basic thing. Now we will hop back into the dictionary. You guys understood the dictionary. We were just adding something, we were replacing something. Now we will go back to the topic where we were talking about the characteristics of the dictionary. Now since I'm talking about the characteristics, it you know that we have key value pair, right? So first we have to deal with the characteristics of the key value pair, then we can talk about the whole dictionary. Okay, so let's talk about key value pair inside the dictionary. So let's say this is key. Now what all data types I can declare inside the key? First we will understand the rules for the key, and then we will see the justification of those rules. So in the key section, you can only declare primitive data type. When I'm saying primitive data type, which means your integer, float, string, and bool, and along with that you can declare tuple from the non-primitive data type. Only these two sections of the data types are supported for becoming a key. Okay, now keys are also unique in nature. Guys, can you see one thing, that it is somewhere looking like similar to the characteristics of sets, right? That's why these data types are supported. Similarly, inside the set only tuple is supported. Here inside the key of the dictionary, only primitive data type along with tuple is supported. Now it is unique in nature. Also, keys are immutable. Okay, keys are immutable means what? Even if you try to change the key once declared, even if you try to change it later, not possible. That's why we say that keys are highly immutable in nature, because we don't have any access to go through that key and change it, right? That's why we say that keys are immutable in nature. Now let's talk about values. We don't have any restriction for the values. Point number 1, for the values, you can declare all data type as the value. Every data type is supported. Point number 2, you can duplicate the values as well, no problem. And point number 3, they are mutable in nature, which means once declared, if you want to change it later, that is also going to happen, that is also possible as well. Okay, so as you can see, any data type is going to get defined with, let's say, their elements property only, right? That's why we are understanding key and values. So let's do the justification of each of the characteristics which we have seen for the key and value. Let's say point number 1, for the key, they are primitive and tuple, right? Suppose if I try to create any other data type as the key, what is going to happen? Let's say this is your dictionary underscore 1. No, let me declare one new dictionary. Okay, inside that new dictionary, as we know that all the primitive data types are supported and non-primitive only tuple is supported. Okay, suppose if I try to declare list as the key, okay, and try to run this, you can see unhashable type list. What is this type of error? It is telling you that you are trying to declare something which is not suitable according to the syntax, okay, according to the rule of dictionary. So you are trying to declare something by breaking the rule of the dictionary, which we cannot do. Okay, so we cannot declare list as the key. Now what is the next thing which we have learned or talked about dictionary? Key, which is unique in nature. Suppose if I try to duplicate the key, what will happen? So this is the dictionary underscore 1 which we have already declared. Now I will try to duplicate this subject key value pair. Okay, so I am declaring one more, or let's say I'm adding one more key as the subject itself. Okay, I'm trying to assign the value to it as, let's say, not known. Then what is going to happen? In that case, if you check your dictionary 1, now it is showing not known. Previously it was showing programming, now it is showing not known. Why? Because overriding of values are happening. We cannot override the values in the dictionary. That's why we say that keys must be unique. Even if you try to duplicate the key, it will take you back to the previous key or old key and try to override the values. Okay, so we have to be pretty much sure about that. Now what is the third characteristic? They are immutable. We don't have any proper justification for that by showing you the practicality, because if keys are not even accessible, how I'm going to check the mutability or immutability factor? I cannot access the key, right? I just only declare the key and extract or fetch the value from it. That's it. That's what I can do. But if I want to touch the key, no possible. That's why we say keys are immutable in nature. Now similarly, if you see the characteristics of the value, they support all data type, they can be duplicated as well, and they are mutable in nature. For example, for all data type thing, guys, this is your homework. Okay, you can declare every data type as your value and you can print it and check it. Very basics. Till now, if we came here, I hope you guys can do this. Right now I'm talking about the duplicacy thing. Suppose if I want to duplicate the value, I want unknown to be here, I want unknown to be listed here as well. So I'm just simply accessing this particular key, let's say subject, and I'm assigning unknown to this. as we know that it is possible that we can duplicate the keys. If you check your dictionary underscore once again, you can see, yes, we can duplicate the keys. And it is going to cause no harm to my dictionary. It is possible to duplicate the key. Okay. Hopping into the next thing, or let's say the last characteristics of the dictionary, which is mutability, which means values are mutable in nature. We can edit it. Suppose if I want to change the name key and value Python, name is going to be intact because it is immutable in nature. I want to change this Python to Java. Can I do that? Of course I can. I'm going to write it down. I can simply write Java here. My key is intact. I am just changing the value, and that's what the property of value says, that you can change it. It is mutable in nature. Okay, so this is all about dictionary key value pair. Okay, let's hop back into the sheet and talk about the dictionary element. Now when I'm saying dictionary element, you guys know we have two things in the dictionary element, key and value. We are going to write the mutability factor on the basis of that, where keys are immutable in nature, values are mutable in nature. What about dictionary itself? It is also mutable. How come? Previously you guys have seen that we have added one value inside the dictionary, which means we are manipulating the size of the dictionary. And if you want to remove or delete something from the dictionary, we do have method present inside the help section of the dictionary. Simply write help, and inside that mention dictionary. You will see, first you will see the definition of the dictionary, new empty dictionary, new dictionary initialized, whatever you can see, everything is there. As I always told you, whenever you jump into the let's say help section, you have to always ignore the method starting with double underscore. Scroll it down, start picking methods from here. Okay, so let's say we want to remove something from the dictionary. You can see something called as pop is there. Okay, and pop item is also there. Let's say if I'm going to write dict 1, this is your dictionary 1, we are having these elements. I'm simply writing dot pop by not mentioning anything inside it. So what you can see, it is asking me to give something inside it. Let's go back to the pop. Remove specified key, which means we have to mention key here inside the pop. So I want to delete the subject key along with its value. Okay, now if you again check your dictionary 1, you will not find that key value pair in the dictionary. Okay, so whenever you mention something inside the pop, it is going to delete that relevant key value pair. Okay, now also let's talk about you can see we can add something in the dictionary, we can remove something from the dictionary. That makes dictionary mutable in nature. Now this table is fully created. I'm suggesting you to take a screenshot of this table because it is very important, right? The mutability factor and immutability factor you must know about every data type. Okay, now set itself is mutable. We can add or remove elements from it. And the fourth one is your dictionary, which we again declared within the same brackets, and it is mutable in nature. Okay, so the only data type which is immutable, you can say it is sets. Let me repeat that. The only data type which you can say immutable is your tuple. Okay, rest every data type are mutable in nature. Okay, now going back to the dictionary, we had yet to cover some things in the dictionary. Let's say this is something which we removed from the dictionary, right? Now there are so many items, guys. If you want, you can use every item. This copy and clear are the same as that of the previous data types, no difference. Okay, so if you want to fetch the keys and values, you can go in this help section of the dictionary and you can pick up the elements. Now one thing which I wanted to show you, which is very important, let's say this is your dictionary underscore 1. Suppose you want to extract only the keys out of this dictionary. Okay, only keys from dictionary. How you can do that? Simply write dict underscore 1, which is the name of your dictionary, dot keys. Dot keys is the method present inside the dictionary which will list down all the keys present inside it. You can see this is how it is going to look like. Now suppose if you want to extract the values, you're going to simply write dict underscore 1 dot values. It is going to extract all the values out of the dictionary for you. Okay, now keys are extracted, values are extracted. There is one more thing called as items, dot items. Okay, so it is going to list down all the key value pair present inside the dictionary. But now this is a question for you. Okay, let me write down the homework question for you. Judge the data type, or no, yes, judge the data type of the elements present inside dict underscore 1 dot items. So what is the question? What it is saying? You have to pick this element up and identify the data type. What data type is it of? Okay, and then we will answer this question in the upcoming session. You have to do the identification. If you guys give me the correct answer, I will say that yes, we are going good with the Python and all the data types. Okay, so yes guys, this is all about your dictionary. Now we will talk about one most important topic in the Python called as memory management. Okay, since we covered the basics of the Python, we have to talk about something which is very let's say below basic thing. We must understand how Python works, right? How memory is getting consumed when I'm writing the code, what all where this data is getting stored, if I'm declaring the data type, where all the variables are getting stored, everything we have to understand. Okay, so for this thing there is one new topic called as memory management, and it is completely a theoretical topic. Okay, let me open one PPT, or let's say one notes for that. Garbage collection in Python. Okay guys, so when I'm saying garbage collection in Python, first we will understand how memory is going to get managed in Python, then we will see what is garbage collection. Okay, now for understanding the memory management, we must go in the visual tutor. Okay, I am copying this thing, will paste that in the whiteboard or blackboard. I'm clearing the blackboard. And can I paste something here? I guess no. Okay, my bad. Let me close this. Let me take the screenshot of this. Okay. No, it is not. No, my bad. Okay, screenshot. No, this is accessing the gallery. It's not accessing my laptop. Wait, let me give it a try. Cancel. It is not picking my folders, so leave it. Chalo. No problem. Let's talk about the memory management in Python. As you guys have seen this thing, right? We'll talk about this thing. This is your frame and this is your object, right? Let me replicate the same thing by drawing itself. No problem. This is your dictionary, and this is not only with the dictionary, it is with any other data type. Your keys are appearing somewhat like this, and your values are appearing somewhat like this: XYZ 60 ABC. Okay, so you guys look into this thing that here it is showing frames. and other thing it is showing as objects. Excuse me. So when I'm talking about frames and when I'm talking about objects, let me write it down. This frames where all the variable names are getting stored. Okay, and this object where all the values are getting stored. Okay, let's say if you, whenever you declare x is equals to 10, what happened? You know that this is identifier or variable, and you know that this is value, right? So what happened? In the frame, all the variable names are going to get stored, and in the object section, all the values are going to get stored. So you will see here one thing, that there is always one arrow which is referencing from the frame to the object section. So we say that Python is nothing but it stores object with the help of references. Okay, whenever we declare something inside the Python, it stores object not directly into the memory but with the help of references. For example, let's say, let me clear this thing. This is your x variable. You have declared x is equals to 10. Now this is your y variable. You have declared y equals to 20. So how the memory is getting managed in the Python? This is x and y getting declared in the frame section. Okay. Now here we are having the object section. Okay. Inside the object section, you will see all the values. Let's say 10 and 20. So to understand this thing, we say that Python stores memory, or let's say Python stores value with the memory reference. What is the term? Memory reference. It does not blindly stores your data set. Okay, it stores your value while referencing it. Okay, which means the x is giving reference from frame to the object side. Y is also giving reference from the frame to the object size. Okay, also understand one thing, that suppose in near future z is equals to 10 is also going to get declared. So what will happen? In the frame section, z will appear, and in the object section, what you guys think, 10 will appear kya? No, it will create a direct reference to the previously declared 10. What it is doing? It is saving your memory. Okay, instead of duplicating the object again and again, it is creating a reference to that object. What if two different variables are storing the same object? No problem, there might be the use of it, but the job of Python is to save the energy, save the memory, right? Efficiently write the program. So this is what memory referencing is. Even if in near future you are getting the same type of value, instead of creating the dummy or let's say duplicate value here, it is referencing to the previous value present in the memory. That is what memory referencing is. Now to this concept, we have a related topic called as garbage collection. Now we'll talk about what is garbage collection. Garbage collection is nothing but it helps us to collect the garbage from the data set. Okay. Garbage collection means what? Garbage collection says that whenever I declare something which is of no use, let's say whenever I declare something inside the Python and in near future it will become of no use, how that data is going to get deleted from the memory, right? How this is going to get deleted from the memory? Let's say we cannot keep everything inside the memory, right? We have to take care of the memory, we have to use the memory efficiently. So in that case, how the garbage is getting collected, the things or the values or the objects which are of no use, how these are getting collected, this concept is getting declared with the help of garbage collection. Now, as you guys know, the in Python, everything is getting stored with the help of memory reference, right? We are not storing everything directly. It is completely with the help of memory reference, and with the help of this memory reference, this garbage collection will come into the picture. Let me take you to the PDF. Garbage collection is a technique used in programming language for memory recovery. Okay, recovery means what? When something is of no use, we delete it. If you want to recover it later, that is also the very important characteristics of the garbage collection. So in garbage collection in Python, manages the memory automatically and heap allocation. So I'm not going to read this PDF fully for you, it will become very boring. I'll give you the PDF. Whenever you get time, you can read it. Let me explain it to you directly. Okay, you guys see, we have heard this thing or learned this thing, reference count, right? So whenever one variable points toward the object, there is always one reference count. Okay, because you know Python works with memory referencing. So let's say if x is referencing to the 10, what is the reference count of x? The reference count of x is 1. Okay, now what is reference count of y? Y is referencing to 20. Reference count of y is also 1. What is the reference count of z? It is also referencing to the 10. It is equals to 1. Okay, look into the thing. Reference count 1 of 57. Okay, now when two different variables are pointing towards similar object, the reference count will become 2. So here, can I say that I am not referencing according to the variable, I am referencing according to the object. Okay, so what is the reference count of 10? It is going to be 1. What is the reference count of 20? 1. Again I have seen that z is equals to 10. Now this reference count will become 2. As long as any object is having the variable, as long as any object is having the reference count, we are pretty much good. Okay, now let's say if I declare some calculation like this, let me erase this one. Let's say I declare somewhat like this, something like this. X is equals to 10, y is equals to 20, and z is equals to x. Okay, now what will happen? I am again declaring the value of x as 30. Okay, now what I am doing? I am going to delete z. Okay, this all things are happening. Whenever you are writing x is equals to 10, no problem. Y equals to 20, no problem. Z is equals to x, no problem. So what is the reference count of 10 as of now? 2. What is the reference count of 20? 1. Okay, x is equals to 30. This reference is going to get breaked, and now x will point out to the new member called as 30. Okay, I am deleting the z as well. Now z is not even there. So previously when the reference of x is broken from the 10, the reference count will become 1. When the reference of z is again gets broke from the 10, the reference count of 10 will become 0. So what we are consuming some space, this 10 is consuming some space in the memory. Now what is the use of this 10? Nothing. Now then 10 is going to be called as garbage. Okay, and this garbage is going to get collected by the Python immediately without any manual intervention of the user. You understanding my point? What is happening? Previously there was a reference from frame to object. Once the reference from frame to object gets broken and the object is having 0 reference count, we say that object is of no use and it is a garbage. How that garbage is going to get collected? That garbage is by default getting collected by the Python. We don't need to do anything. It happens time to time. Okay, it is going to happen in a loop, and with time to time it collects the garbage. Okay, so that is what garbage collection is. No worries, I'll pass on you guys the PDF. You can read the PDF. This is a similar thing which we have done right now. It is explaining you in the technical terms, so that in near future, if you want this if you want to explain this thing to someone else, you can do that as well. Okay, so I'll give you the PDF, what is garbage collection, how this happens, what actually the garbage is, and what is the purpose of doing garbage collection. Okay, so till here we are done with all of your data types. We are done with your memory management and garbage collection. Now from the next lecture we'll be starting with the operators. Okay, now once you are done with the data types and the operators, you are good to go to write any Python program. So let's say after 1 or 2 lectures we'll be writing programs in Python. Okay, so yeah, that is it for today guys. Thanks for having me. We'll meet again soon.